Hello everyone, so we're going to be talking about identifying an unknown isotope. And so I'm going to step you through this, and we're going to follow the COAST method. So we're going to collect, organize, analyze, solve, and think. Collect, we're underlining important information. So as we go through and we read this, we should be grabbing that info. Lithium has an elemental atomic mass, or average atomic mass, of 6.94 U. This could also be grabbed off of the periodic table. Those mass numbers on the periodic table are the average atomic mass of the elements. And has two naturally occurring isotopes. So we have a lithium-6 and then our unknown. So the mass of lithium-6 is 6.0151 U, and its percent abundance is 7.49%. Lithium of the unknown has a percent abundance of 92.51. Okay, so we want the mass of lithium-6. We're going to want the percent abundance, and then we want the percent abundance of the unknown. And we're going to determine the unknown isotope, and so we need the mass number, which is going to be really close to the mass of this unknown isotope. So now that I've collected, I'm going to organize this into a list of knowns and unknowns. So like the average atomic mass, 6.941 daltons, and then the mass of lithium-6 is 6.0151 daltons. The percent abundance, but remember when we're doing this, we don't want to keep it in the percentage form. Like to get that percent, we had to multiply it by 100, and so we want to divide by 100 or move the decimal to the left 2 times. This is a common mistake that students make. I have lots of students that tell me 0.749. Then if we divided by 10, that would be the case, but we needed to divide by 100. So we have to move that decimal 2 times. So this like fractional or decimal form of the percent abundance for 6 would be 0.0749. We're going to solve for the mass of the unknown, and then the percent or decimal form or fractional form of the percent abundance of the unknown is going to be taking that percentage, dividing by 100, or moving the decimal to the left 2 times would be 0.9251. Now that we've organized this into a list of knowns and unknowns, let's analyze using the average atomic mass equation. So you're going to need to know that average atomic mass is going to equal the mass of one of the isotopes, like the mass of 6, multiplied by the decimal form of the percent abundance for 6, and you're going to add that to however many isotopes there are. So since we only have 2 isotopes, there's only one more parentheses that we're adding here. So it's going to be the mass of the unknown multiplied by the decimal percent of that unknown. When I look at my list here, I know everything except for what I'm solving for. Like we have the average atomic mass, we have the mass of 6, we have the decimal form of the percent abundance for 6, we're solving for the mass of the unknown, and we know the decimal percentage of the unknown. So our goal is to rearrange this to solve for that unknown. And notice this whole component here is added to this. So my first step is going to be subtracting this whole thing to the other side. So it's like minus the mass of 6 multiplied by the percentage of 6. And then we're going to do that here and there. So I would have average atomic mass, but then I'm going to subtract this. So minus mass of 6 multiplied by the decimal percentage of 6. And then what we're left with is mass of the unknown times by the decimal percentage of the unknown. We don't have to keep these parentheses if they're the only items over there. And that will help us to recognize that we're only one step away. Since the percentage is multiplied, to get this completely isolated, we would divide both sides by that percent abundance of the unknown. So I'm going to just divide this half so that it cancels, and I'll divide it over here. So the final iteration of this equation would be average atomic mass minus the mass of 6 multiplied by the decimal form of the percentage of 6, and then this whole thing over the decimal percentage of the unknown. And then that will give me the mass of the unknown. So that's our analysis. Like, we started with this equation, we rearranged it to get our unknown. So now we're going to solve. We're going to plug this in our calculator. Your calculators are wonderful tools, but you need to tell them that this whole thing needs to be on top of the fraction. And so I would add another set of parentheses in there. We want this whole thing divided by that number. So if I was plugging this in, I would go parentheses, and then I have my average atomic mass minus, now I'm going to open up my second set of parentheses, the mass of 6 times by the decimal form of the percentage of 6, and then I'm closing the parentheses and then closing the top of the fraction, and I'm going to divide by the decimal form of the percentage for the unknown. Okay, so I got, for my unknown, let's see, 7.05. Okay. This is a mass, though, and we've noticed all the other masses had units of Daltons, or this lowercase letter u. So now that we've solved, let's think about this. Is this a reasonable answer? Because the average of these two isotopes would be 6.941, and then the mass of 6 here, and so that's below this average, so the other one had to have been above it. But not an unreasonable amount, right? This isn't 70, but 7 would be just above that. So yes, that's a reasonable answer. So I'm going to put a box around it to indicate that that's my final answer. Okay, so that's the method that you would take to solve for the mass of an unknown isotope. If we want the identity of that unknown isotope, well, this is still lithium, right? It's an element of lithium. And then we'd round the mass to the closest whole number, and so the identity would be lithium-7. All right, guys, if you have any questions, feel free to email me.